guys, welcome back to another tutorial on OpenCV with Python. So today we are going to know how to change the colors and everything of the images. Now in OpenCV, it usually reads in BGR, not RGB. If you know what that is, blue, green, and red. So we can change the format, the color of the format to different other formats as well. So let me show you. uh, just let me look at this code, and then I want to show you. So let us now write the code of changing the colors. So let us first change it to gray. So let me call this gray is equals to cv2 dot cvt color. Okay, cvt color is the command to change the color. So let us give the source. The source is img, and the code is cv2 dot color bgr. Okay, so let's now do this image and show. Let's call this gray. Sorry, gray. I think that's done. So let's run this code. Yes, as you can see here, we have got this gray image. Now let us change it to some other color. Let us change it to HSV. So let's call it HSV. Sorry for the introduction. HSV is equals to CV2 CVT color. Pass in the image, and CV2 dot color. Let's see here, BGR to color underscore BGR. Okay, it is BGR to HSV. So now let's show. CV2 dot show. It's HSV and pass in. That's done. Let's run this code. As you can see, this is the HSV picture. Now you can also change this to another format. I just copy this line here and change this to. I'm going to change this image to RGB. Okay, so let's call this RGB is equals to RGB. Let's now CV2 show. Let's call this RGB. Okay, so let's now run this. This one is the this one is the RGB image. You can see this. So now the next what we can do is let's just clean this lines and just keep the gray. Okay. Hello. Okay, in the last tutorial we saw how to change the color of the images. Now today we're going to learn about blurs and finding contours, so and edges. So let's do this. So let's start with the Gaussian blur. So let's call it G blur is equals to cv2 dot Gaussian blur, then pass in the image, Then the kernel size, let's give it 7,7. And if you don't know what the kernel size is, you can of course read it, but the kernel size is the width and the height, and they differ, but they must be put positive and odd. Okay, so it's a deviation in x direction, and the sigma y is a deviation in y direction. Okay, so I think that's okay, but that I make a mistake. So first let us do this cv2.show. Let's give it Gaussian, Gaussian, comma G blur. Here we go. I think I forgot to put the what. Okay, no, it's okay. Sorry. So you can see that the image has blurred a little bit. Now what it does, you can see here. Now as I increase the kernel size, it's gonna increase. So let's make it 9 by 9. So we can think of the kernel image as you know it is like little boxes, and it is blurring each one of them by 9 into 9 grids like that, and in the x direction. So as you can see, it has blurred a little bit more, so like this. Now the next thing is finding uh, edges and contours. So for that, we are going to use the command canny. Okay, so let's call this canny is equals to cv2.canny, pass in the image. Always pass the gray image because that's better. Then the threshold one, let's call it 125, and then threshold 2 of 255. Okay, and I think that's enough. So let's now display this cv2 show. Let's call this canny and pass canny. Okay, I think that's done. Let's run this code. Sorry. So as you can see that we have got the canny image right here, but there are other methods as well. So let's do one thing. Let's do some thresholding of this image. So let's call this red comma thresh is equals to cv2 dot threshold. Okay, then give the gray image, give the, I'm gonna give it 120, the maximum value of 255, and the type. So you can write here thresh, so it's cv2 dot cv2 dot thresh binary, and then you can just display this image cv2 dot show. So let's just do this. Let's call this thresh, and let's pass in the variable thresh. Okay, now let's run this code. Yeah, as you can see here, this one is the thresh image and this one is the canny image. Okay, now what you can do is that we can take this thresh and print it and draw it on a blank image as well. But before that, we need to find the contours. So let's do this. Contours, let's call this contours is equals to cv2 dot find contours, then the image, contours and hierarchies. Sorry, hierarchy. Is the image, and then pass in the mode for the contours. Okay, so we have to give is cv2 dot retter list or retter tree for all of them. And retter is, you can see there are different retter list. And this one is for only for the external parts of an image, and this one is for this. And I'm gonna give it retter tree, and then another one cv2 dot chain approx none, chain approx, sorry, chain approx. Now what you can do is you can just uh, print the number of contours as well. So just write down print. Let's call this contours, contours plus plus contours. Yes. Now I have passed in this image and I'm trying to find the contours. So if I run this, now let's just do one thing. Let's just uncomment these lines of code and let's run this. Okay, I think there is some mistake. Chain approx none. Let's pass in the gray image. Image and see. You can list to string. Sorry, I just need to change this str. Sorry for that. And then okay, and then okay, this. So just got to write that much code. Okay, this that's better. Let's see if this doesn't work. Then okay, so you can see there are only one contour here. So in this gray image, but let's change this to the normal image and let's run this. It can only find the contours, so as you can see it's not showing anything because it can only find the contours in the gray image. Okay, so remember that to always pass the gray image. Now if I just change this to another image, say okay, let's see, new faces this dot jpg, change the color, just that. Oh god, just forgot to change this. Let's pass this gray. Now this is the image. Okay, this is the image and we are going to find the contours. So let's see, because there are 226 contours as you can see here. Now what we can do is let's just uncomment this line of code and let's just uncomment this line of code and let's see. Now that's done, let's do something. Let's draw this thresh on another thing, on a blank image. But before that we need to create a blank image, so we need to import numpy. So let's do import numpy as np, then create blank is equals to np dot zeros, then give im image, so img dot shape, not shape, bracket this 2 Okay, and then comma, uh, d type is equals to uint8. Okay, that's done. Now I have to bring this one on the front. Let's create this one. Now if now let's do cv2.unshow. Let's give call it blank, comma, comma, and then blank. So let's now run this code. Now you can see that it will create a blank image whenever we pass this much line of code. Image.shape img.shape is to it's going to create the blank image similar to the size of the original image. So remember that. So what we did, we finished it here. So next is we need to draw the contours on the image using the cv2.drawContour methods, and we have discussed till here. So let's draw this. So before even I start again, let's do this thing. Let's do a recap. So we are importing cv2, then we are importing numpy as mp, then we are reading the image, then we are creating the blank image of the same size of the original image, then we are converting this to gray, then we are finding out the threshold image, and then we are finding the contours. Now we need to draw the contours on the image. So in order to do that, we are going to do is cv2 dot draw contours. Okay, then pass in the blank image. Okay, then give the color. So I'm gonna give it this color. Whatever color you want matters totally on you, and I'm going to give it a thickness of 2. Then before that I need to pass in the contours, then -1. Okay, so -1 means all the contours, and I want to draw the contours which are these contours. So next we want to display the display this image, so let's call this draw, and then plus in the blank image. Now that's done, let's run this. And as you can see that we have got this image, which is the threshold image. Now what you can do is you can even do one thing. You can even draw on the original image. Just change these things. You can see that you are drawing on the original image. So you can also do that, and that is the thing. So drawing contours and everything on this thing.